Hello friends, today we are going to solve this integral over here, that is e to the power 2x into cos of x dx. Mostly we solve this integral by using integration by parts, but today I will discuss and solve this integral by a much easier method that will solve a lot of your time to solve such integrals. So by using Euler formula, that is simply e to the power iota x equal to cos of x plus iota sine of x. Now you can see that this cos of x over here is my real part of this e to the power iota x, and this sine of x is simply my imaginary part of this e to the power iota x. Now by using this equation, this formula, I need to integrate this integral over here. So what if I substitute the values of cos of x in this integral and solve it out? So as cos of x, here you can see cos of x is the real part of this e to the power iota x. So then it becomes real into integrate this e to the power 2x e to the power iota x into d of x. Now as we know that if our bases are same, as you can see both bases are same, when bases are same is a lot of exponent that you need to add the powers. So when I add the powers and solve this out, this becomes e to the power 2 plus iota into x into d of x. Now this is really simple, super easy. I need to integrate e to the power 2 plus iota into x. So this becomes real part of e to the power 2 plus iota divided by 2 plus iota x divided by 2 plus iota plus c. Now just you need to plug in the value of this iota x, e to the power iota x, that is simply cos of x plus iota sine of x. So what I will get is simply real part of e to the power 2x dot e to the power iota x divided by 2 plus iota plus c. So I will substitute e to the power iota x as cos of x plus iota sine of x. Then this becomes a real part of e to the power 2 of x divided by 2 plus iota into cos of x plus iota sine of x plus c. Now I need to put this in the form of a plus b iota, which is the standard form of complex numbers. To convert this into a plus b iota form, I just need to take the conjugate. To take the conjugate, I will multiply and divide this by 2 plus 2 minus iota, sorry. So if I multiply this with 2 minus iota, what I will get e to the power 2 of x cos of x plus iota sine of x divided by 2 plus iota multiply by 2 minus iota divided by 2 minus iota. I am taking the conjugate. So as we all know that iota is equal to root of minus 1 and iota square is equal to minus 1. Iota square is equal to minus 1. So when you solve this out by multiplying this and taking the conjugate, what you will get is e to the power 2x divided by 5 into 2 cos of x plus sine of x, and my imaginary part is simply 2 sine of x iota plus minus cos sine of x cos x iota. So you need to solve this out by pausing this video and you will get this answer over here. So this is how we can use Euler formula to solve such integrals that takes a lot of time if we solve them by integration by parts. So this is a super easy formula that you can use to solve such integrals.